Hello everyone again and welcome to our machine learning tips. I know it has been a while since I recorded a video. So I did promise I was going to be posting a lab on the decision trees, random forest, and the extreme gradient boosting algorithm, which is an example of the gradient boosted trees. So today we're looking at building models using decision trees, random forest, and the extreme gradient boosting algorithm. We will still be using that tumor, the breast cancer data set, which is like classifying tumors into malignant and benign. So in this lesson today, we'll be looking at building, how single decision trees work. Also, we will look at the how random forest can reduce overall variance via debugging and future randomness. We will also look at the extreme gradient boosting algorithm. So the first thing we have to do is first of all to import the libraries we were going to be using. We will be loading this data set from the scikit-learn data set, and then we'll also be using the train split, which is from scikit-learn 2. Now I don't bother. We are not going to use this pre-processing from scikit-learn because I did mention earlier that when you're using this decision tree-based algorithm, there is no need scaling your data. Then still from scikit-learn, we are going to be importing the accuracy score, the confusion metrics, and then as well as the classification report where we are going to be looking at how we evaluate that model using precision recall and so on. So from the since we are going to be using the decision tree classifier, we are going to be importing from scikit-learn. We are going to import decision tree classifier, and then here we also want to plot that decision tree to look at how to see how it looks like. Because I did mention it is easier to interpret the decision tree compared to random forest and the extreme gradient boosting algorithm. One thing you have to note from here, if you are going to use this extreme gradient boosting algorithm, you have to first of all do a pip install on XGBoost. So you have to know this because it doesn't come with the scikit-learn like the decision tree and the random forest classifier. When you do that, we have to run this setup, for the libraries we are going to use. And then now we imported the data set, we are going to load it and then convert it into a pandas data frame with those names. Then from here, we need that target variable as well as, we can do the shape to look at how the distribution of that data looks like and so on. We have been doing this a lot. It just shows us the number of benign classes and malignant in that data set. We have been doing that a lot. So we will see do our test splitting that data. Remember, as I said, we are not going to be scaling anything. We don't need to scale it. We'll run it, and here we are using the stratifier method when we are splitting these data sets so that there is an equal chance of the malignant and benign class, especially for class imbalance problems. But in this case, we can clearly see that there is not a lot of discrepancy in between these classes. So, but it is a good way to use the stratified method when you are, when we are splitting that data. Stratify, we are equating it to y because y is the target variable. Now, the first model we'll be using is a decision tree. First thing, we imported the decision tree classifier. We'll just call it, and then we do a random seed is equals to 42, please. And then we will do feed with sending the train and the training x here, which is like the number of futures, and then we also have the target, and then we are going to predict from the test set. We will run this. So when we run this, we are going to see that the accuracy of that model is like 91%. We also have the confusion metrics here, also showing the number of you see. So in the test set, we can see that the number of the malignant class, they are a total of just 42 in the test set, and we see that the model was able to get 39 out of that 42. And also for the benign class, we can see that there are 72 of them, and the model was able to get 65 correct. So then, as I did mention earlier, we can also look at plotting that decision tree to see how those futures are being splitted, which we see how the splitting occurs here. And To do that, we use that plot underscore tree, and then we pass in that decision tree. Also, I also did mention earlier that we can do future importance, where we can look at the top 10 futures, which was the most performing future, or the future that had a lot of significance in this model. We can see that it is what? The waist radius. And we can see that the one that has the highest score here is the most top future that contributed a lot in that model. So then we also looked at the random forest classifier. We are going to use the same way. We call that random forest classifier, and then we feed it with the training data, and then we are going to do a prediction on the test set. If I run this, we can see that the decision tree, the random forest model has an accuracy of 95%, which is, easily saying that, decision trees, as I did mention, they can reduce variance as much as possible. And also we can see that out of the benign class, which were 72 from the test set, our model got, the random forest got 70 out of the 72 compared to the decision tree that only got 65. And also we can see here that, the future that contributed a lot in that model is still that waist radio and so on. So we move to the extreme gradient boosting classifier. See, we imported it and alias it as XGB. We are going to do XGB classifier because we are using the data set is a classification data set, and then we feed it the same way we do for the other models, and then we run it. So when we run it, we can see here that the extreme gradient boosting algorithm, the accuracy is pretty similar to the random forest. And also we can see here that out of the 72 benign classes in the test set, it got 70 right, but there is some discrepancy when it comes to what the malignant class. It only got 38 out of 42 of them correctly, compared to, we see that for the random forest and decision tree, they got 39 out of the 42. So we can see here that out of this model, the better one that performed pretty well here is what is the random forest classifier. So we can also look at, how to, how this result look like. It doesn't matter which of the models we are using. So if I run this, we should be able to, why? No, thing is because this if statement here, let me get this backward, should be able to work. Let me run this to see side-by-side result. This is just showing us, how model comparison. We can see here that the random forest outperform both the extreme gradient boosting algorithm and the decision tree. So meaning that if we were to deploy a model to predict this tumor, we are going to pretty go with what? The random forest classifier, as opposed to what the extreme gradient boosting algorithm and the decision tree. So one thing I want you to try is, I did mention that we have different parameters for these models. You can go with the extreme, like the decision tree. You can try the number of depth, maybe 2, 4, or 6, and then try to see how it performs. Also with the random forest, you can also change the number of estimators as well as the maximum depth and also see what happens. Also, I did mention earlier with the extreme gradient boosting method that they are very sensitive to those parameters. So one thing you can do is the learning rate is very sensitive. You can try to change it to different values and see what happens. That will be something I want you to try on your own. And then you can ask questions whether in the comment section, but on my YouTube channel as well as on Facebook. So today's lesson, we actually covered decision trees, and then we also looked at how we can interpret them because we plotted those, and then also looked at random forest, then also the extreme gradient boosting algorithm. We looked at how we evaluated these models, and the best that we could choose from here is what is random forest in trying to predict this breast cancer into benign and malignant. That was it for this lesson today, guys. Keep following for more tips in machine learning. Thank you so much.